So before we get into some actual problems, you need to review some area formulas. And these are the area formulas that we've done so far this year. You might want to take a quick picture of this, pause the video, write these down and refresh your memory on all these shapes, because these are the majority of the areas that formulas we're going to be referring to. So I know that there are formulas that other books use, but I don't do surface area that way. I'm going to do surface area on a case-by-case basis, meaning each face individually. I'm going to treat this rectangular prism in this case. This rectangular prism, I'm going to treat it as the 6 rectangles that it is. So I'm going to get the area of the top, the bottom, the left, the right, the front, the back, and add them up, and that's my total surface area. Okay, so let's start. Let's say I start on the bottom. The bottom is a rectangle. And to get the area of a rectangle, I would do base times height. So if I do 13 times 7, that would be the area of the bottom. And 13 times 7 is 91. So the area of the bottom is 91. Now, fortunately, the top of this rectangular prism has the same dimensions. Okay, it's going to be 13 by 7 again, so it'll be 91 again. Now I'm going to go to the left side. The left side is another rectangle. It is 7 by 9. Okay, that is the left side. Another rectangle, so I'm writing down the area formula for a rectangle. 7 times 9 is 63, and the right side would be the same. So I'm not going to recalculate that. I'm just going to write 63 again. So I've done the bottom, top, left, right. Let's do the front and the back. The front is another rectangle. Its dimensions are 13 by 9. Again, the front is another rectangle, 13 by 9. And if you do 13 times 9, you're going to get 117. And the back would be the same because it has the same dimensions. And your area for the back would be 117 as well. So you've done the area of the 6 surfaces. So now what you do is you would add those numbers together. And if you add all those numbers together, you're going to get 542. Now again, it is an area application. So 542 square feet. Area answers are in square units. Now, before we continue, I know what some of you are thinking, I don't want to do it that way. I found this other formula on the internet that says SA, which by the way, SA stands for surface area, is 2LH plus 2WH plus 2LW, where L, W, and H stand for the length, the width, and the height of a rectangular prism. So let's try it that way and see if you get the same formula. It would be 2 times 13 times 9 plus 2 times 7 times 9 plus 2 times 13 times 7. Would that give you the same answer? And the answer is absolutely. 2 times 13 times 9 is 234, and 234 would basically be both of those put together. And 2 times 7 times 9 is 126, and 126 would be the left and the right put together. And 2 times 13 times 7 is 182, and 182 is the top and the bottom put together. So yes, absolutely, adding them all up would give me the same answer, 542 square feet. So then why not do it that way? Because that way only works for a rectangular prism. If you have any other kind of prism, that formula does not work. And that's why I don't like to use that formula. So case in point, next example. This is a triangular prism. And that formula that I just had right now would not work on this triangular prism. Notice that on this triangular prism, there are 5 faces. There's 3 rectangles around the sides, and then you have the 2 triangles, 2 right triangles in this case, on the top and the bottom. So I'm going to start with the top. The top is a triangle, so I'm going to use the formula for the area of a triangle. Specifically, it's a right triangle because the bottom one is a right triangle, so the top one is as well. And if you remember with a right triangle, the legs are the best thing to use as the base and the height. So if you do 1/2 times 9 times 12, That's going to be 54. So that's the area of the top. And that would also be the area of the bottom, because the top and the bottom are congruent. Okay, so you have the area of the top, this triangle here on the top, and you also have this triangle on the bottom because they're the same. Those are the base areas. But now we need to get the lateral areas, the areas of the 3 rectangles around the side. Now each rectangle is different. This rectangle in blue is going to be 15 by 16. Okay, and that is the rectangle in the front in blue. Base times height would be 15 by 16, and 15 by 16 is 240. And then you have this rectangle on the back right, and if you have this back rectangle on the back right, that rectangle is 12. Let me write down the formula, I'm sorry, I like to be consistent. 12 by 16, not the same size, not the same dimensions as the blue one, and that would be 192. And then you have this rectangle on the back left, and that one would be 9 times 16. So 9 times 16 is 144. So these three would be the lateral area, LA, lateral area. That doesn't stand for Los Angeles, it stands for lateral area. If they ask you for only the lateral area, you would only do those 3. If I ask you for the total surface area, you would add the top and the bottom as well. So if we add everything, we're going to get 684 square meters. And that's the answer for that one, the area of that triangular prism. Okay? What about if we have something different, like this one? Well, that's another triangular prism. This one is a trapezoidal prism laying on a lateral face. It's a trapezoidal prism laying on a lateral face. Now, even though it's laying on a lateral face, okay, the 2 congruent trapezoids would still be considered the bases. There's one there in red and the other one here in the back, and those are identical. So get the area of 1 and multiply by 2. And then there's 4 rectangles around the side, so 6 total faces in this one. Those lateral rectangles, even though it's laying down, you still consider the 4 rectangles together to be the lateral area. You would have to add those to the 2 base areas. So let's start with the front and the back in this case, which are the 2 bases. Okay, let me just say that, do the front, and then we'll just add the. Okay, so if we do the front is a trapezoid, so it's 1/2 times the height times the sum of the bases. Now the height of the trapezoid is the perpendicular distance between the parallel sides of the trapezoid. You're only focusing on the trapezoid. Okay, so the height of the trapezoid is 12. And then the bases of the trapezoid are the parallel sides, which are 23 and 18, because that's 18. So if you add 18 plus 23, you're going to get 41. So 1/2 times 12 times 41. So that's going to give you 246. Now again, that's going to be the area of the front, and that's also going to be the area of the back, because the back is the identical trapezoid. Now let's do those 4 rectangles on the lateral surface, okay? This rectangle here in green, let's call that the right, if you will. That would be base times height, and that would be 20 by 15, which is 300. Then let's go to the rectangle on the top, okay? So if we go to the rectangle on the top, outlined in purple, that would be 18 by 15. 18 by 15 is 270. And then we're gonna go to the one on the left. Let's do this in round. Okay, and that rectangle on the left is 12 by 15. And if you multiply 12 by 15, you're going to get 180. So now we're missing the one on the bottom. Let's see what color I can use for that. Let's use this light blue. The rectangle here on the bottom, that's 23 by 15. So if I do 23 times 15, that's going to be 345. So these here, if they ask you for just the lateral area, sometimes they will. If they ask you for just the lateral area, it would just be the 4 rectangles on the side. But I'm asking you for the total surface area. So if you do the total surface area, that's all the faces, that would be 1,587 square feet. That's the total surface area. That's adding all 6 faces. Okay? Now, will they always be shapes like this? No. Let's show some other ones. Here we have a regular polygon. Ooh, so it's a pentagonal prism. Now, they're very nice here on this one on the left, because on the one on the left, notice that they give you this capital B. Now, what is that capital B? That capital B stands for the area of the base. So they are giving you the area of the base. They're giving you the area of that pentagon. And if the area of the pentagon on the bottom is given, the area of the top pentagon would be the same. So the top area, they're giving it to you, is 84.3, and the bottom area is also 84.3. Again, they gave it to you. They were very nice. Now, as far as the lateral surfaces, because this is a regular pentagon base, then all of these rectangles along the lateral surface are all going to be the same. So to get the lateral area, what I'm going to do is I'm going to get the area of one rectangle, and I'm going to multiply it by 5 because they're the same. So it'd be 7 times 4, or 28. That's the area of one rectangle. And then I'm going to multiply that by 5. So if I do 28 times 5, that's going to be 140. So 140 square feet would be the lateral area. Add to that the 2 base areas for the top and the bottom, and the total surface area for this one would be 308.6 square feet. Okay? Now, will I always give you the area of the base for a pentagonal? I'm sorry, for a regular polygon? No, I won't. Sometimes you're going to have to calculate it yourself. And again, we've done this before. Remember when we had things like the hexagon on the left? Let's say that this is, let's just make a number. Let's say that this is 8 inches and that this here, not drawn very well, this height of this is 5 inches. So if I ask you to get the surface area of this hexagonal prism on the right, then you need to get the area of the 6 rectangles along the side, and then the regular hexagon on the top and the bottom. So this time I'm going to start with the lateral area, only because it's going to be a little bit easier. Okay, to get the lateral area, like we did before, the lateral area, it's going to be the area of one rectangle times 6, because they're all going to be the same. This is a regular hexagon base, so times 6. So it'll be 8 times 5, and then that times 6, because there's 6 rectangles around. So 40 times 6 is 240 square inches. That's the lateral area, the 6 rectangles along the side. Now let's do the top and the bottom, okay? The bases. So to do the top and the bottom, we need to analyze what's happening here. So I'm going to draw this a little bit neater. You remember, for a regular polygon, the formula was 1/2 ANS. Okay, now we do know S is the length of one side, it is 6. Okay, we do know N is the number of, the length of one side is 8. The number of sides is 6. What we don't know is the apothem. If you remember, there's several ways of doing this. The way that I showed you was We try to get the measure of each of these angles formed by connecting the center point to each vertex. How do we get the measure of that? We take 360 and divide it by how many there are. In this case, there's 6. So each of these angles will be 60 degrees. In particular, this one here is 60. Now, because each of these triangles is at least isosceles, when you drop that altitude, okay, which is the apothem, that's also going to be a median, dividing it up into 4 and 4, and it's also going to be an angle bisector, making each of these angles 30. Focusing in on one of these triangles, and I'm going to draw it here a little bit neater, we have this is 4. I need this side, and this is 30 degrees. Now, if it wasn't 30 degrees, okay, I would use trigonometry. I can still use trigonometry with 30 degrees, but I'm going to use my 30, 60, 90 rules. I'd rather do that. Since I have the shortest side opposite the 30-degree angle, the longer leg would be that number multiplied by the square root of 3. So my apothem is 4 times the square root of 3. So it's 1/2 times 4 square root of 3 times 6 times 8. And that would be the area of just one of those hexagons. So again, let's get an approximate answer. 1/2 times 4 times the square root of 3 times 6 times 8 gives you about 166.3. And that would be the area of one of the bases, but I'm going to multiply it by 2 because there's 2 identical bases. So that gives me 332.6. So this would be the area of the top and the bottom bases right here, and then add to that the area of the 6 rectangles that are on the lateral faces. So if you add all that, your grand total is 572.6 square inches. And that is the area for this surface, for this hexagonal prism. Now, moving on. What about for the round shapes? For the round shapes. The round shapes consist of cylinders. Right now, we're going to stick to the 2 base shapes, but a cylinder. For a cylinder, I am going to focus a little bit more on a formula, okay? And why? The reason is that for a cylinder, if you open up the net and lay it out flat, it would look like a rectangle, which is the lateral surface, not drawn very well. And then you'd have a circle on one side and a circle on the other side. This is what the net for a cylinder would look like. So to get the area of a circle, we know it's pi r squared. That would be the area of one circle. But because there's 2 circles, that's how you get this 2 pi r squared part of the formula. That's where you get this 2 pi r squared part of the formula from the fact that there are 2 circles. Okay? Now, there is also a rectangle here. And the height of the rectangle would be the height of the cylinder. Now, the base of the rectangle has to wrap perfectly around the circle. This has to wrap perfectly around the circle. And we know that the distance around a circle is circumference. So the base of the rectangle has to be the circumference of the circle. That's where you get the 2 pi r from. That's the formula for the circumference of the circle. And then 2 pi r times h would be 2 pi rh, which is the other portion of the formula. So that's where the formula for the surface area of a cylinder comes from. If they only want the rectangle portion, then it would just be 2 pi rh. I would prefer capital H. But if they want the 2 circles also, then you would need to add pi r squared 2 times, or 2 pi r squared if you put them together. So let's do an example. Here I have an example as I'm looking at the time, and I want to make it a little bit moving along because I have another 2 things to do. So the area for a cylinder here I have the work shown. Again, if I just want the lateral area, it would just be this 2 pi r h portion of the formula. But for the full surface area, it would be 2 pi r squared plus 2 pi r h. Okay, so 2 times pi, radius is 11, height is 26. Plugging everything into the formula, 2 times pi times 11 squared plus 2 times pi times 11 times 26 gives you 2 times pi times 121, or 242 pi for the area of the two bases, and then 2 times pi times radius times height gives you 572 pi for the lateral area. Since they're both like terms, they both have a pi, you can combine them to get 814 pi square yards. That would be your exact area. Plugging in an approximation of pi, preferably the pi key in your calculator, gives you this 2,557.3 number. Now, if you look at this example over here on the right, this is a cylinder laying on its lateral surface, but this is still a cylinder. Okay, please be careful. The radius would still be halfway across a circle, even if it's laying sideways. Sometimes they give you the diameter, like in this case, diameter is 15. Radius would be half of that, 7.5. The height is the perpendicular distance between the circles, even if it's laying sideways, so the height is still 9. So you'd still plug into the same formula, but be careful what you plug in. Okay, another thing you're going to be dealing with in tonight's homework is composite 3D shapes. That means two shapes put together. This composite object is basically two prisms put together, a rectangular prism on the bottom and then a triangular prism on the top, laying on a lateral face. Now, when you do surface area, you would only do the surface area of what is exposed. If something is covered by something else, then you would not include it in your surface area calculations. So let's do this together. Okay, let's start with the triangular prism on the top. The triangular prism on the top, you're dealing with a rectangle here in blue. Its dimensions are 15, that's how much this is across, 15 by 9, okay? And it seems like the one in the back is also 15 by 9 because they give you this edge here for this one in the front as 9, and they give you this edge here for the one in the back as 9. So both of those rectangles on the top are 15 by 9, okay? So we have two rectangles. Each of them is 15 by 9. That's the only reason why I'm combining them, because they're identical dimensions. So 15 times 9 and then times 2, because there's two identical ones. So if you do 15 times 9 times 2, you're going to get 270. So just to be clear, that's this rectangle here in the front and this rectangle here in the back. Now, you have triangles on the side, and those are also identical. The base of the triangle would be this edge, which is 9 for both. Now, the height of the triangle, I would need to know how much this is, the height of the triangle. I don't know, it's not a right triangle, so I can't use the sides. I need to go ahead. It's actually equilateral. That's 9, 9, and 9, okay? So what you're gonna have to do here is, yes, you can use your tricks that you know for the height of an equilateral triangle, but you can also do something else. But you can also get the height from the fact that they gave you that the height of the entire solid this way is 19.8. This edge is 12. So if this is 12 here, that means that this edge here would be 12 as well. So you have part of the height already given, not drawn very well, but part of the height already given is 12, and for the prism portion at least. And then you have 19.8. This is not drawn very well. 19.8 is the whole thing. So if you subtract 12 from 19.8, you're going to get 7.8. So the height of that triangle would be 7.8. So now what you do is let me go ahead and do this in green. To get the area of the two triangles, I'm going to do half base times height times 2. I know what you're thinking. Why divide by 2 if you're going to multiply by 2? You don't have to do that if you don't want to. But the base of this rectangle is 9. The height of this rectangle is 7.8, and there's 2 of them. So if you go ahead and you multiply those, and this is not wanting to move for me. If you go ahead and you multiply those, your answer would be for those two things, 9 times 7.8 would be 70.2. Okay, so that's all you're dealing with in the triangular prism. Notice that one of the faces of the triangular prism, which would be this rectangle here, this 15 by 9 rectangle there, we do not use because it is covered. And that's also the top of the prism on the bottom. It is covered by the other prism, so we don't count it in our calculations. So I'm done with the top shape. Let's do the bottom shape. The bottom shape is a rectangular prism. What surfaces are exposed here? Okay, well, we have this 15 by 9 rectangle on the bottom. Okay, we only have one of those. So if you get the area of that rectangle, that 15 by 9 rectangle on the bottom, that's going to be 135. And then we have this rectangle here in the front. Let's try to use a different color. This rectangle here in the front, its dimensions are 15 by 12. And the one in the back would also be 15 by 12. Okay, so front and the back, again, since they're the same, I'm combining them. So that's going to be 15 by 12 by 2, because there's two of them. So 15 by 12 by 2 is 360. And then what I have left is, let's use this pink color. This green rectangle, I'm sorry, green, this pink rectangle, that is a 9 by 12. So that would be the left and the right. That's 9 by 12 by 2. So if I do 9 by 12 by 2, that's going to be 260. Again, I do not do the 15 by 9 that's covered on the top of that rectangular prism. I only have one 15 by 9 because only one is exposed. So now I can add all of these numbers together. And if I add all these numbers together, I get a grand total of 1,051.2 square feet. Okay. Okay, now last thing, something else you're going to be dealing with in the homework is with word problems. It might not say find the surface area, no, it will have keywords. The keywords I always told you with area involve the word square units, in this case, square feet. So you have this huge silo, this huge metal silo that you are going to cover with a rust-proof coating. Every gallon of the coating covers 1,000 square feet. How many gallons will you need? Again, this is one of the reasons why I like to show you where the formulas come from so you can adjust them as necessary. The formula for the surface area of a cylinder is 2 pi r squared plus 2 pi rh. This comes from the fact that there are two circles, and this comes from the fact that you have one big rectangle, the lateral surface. However, this silo is a heavy metal object. You're not going to pick it up off the ground and paint the bottom. So you're not dealing with two circles in this case. You're only dealing with one. So since you're only dealing with one circle, we can eliminate this 2 in the front to reflect that we're only dealing with one circle. So it's just pi r squared and then 2 pi rh for the lateral surface. So again, diameter is 20. Be careful that you know what you're dealing with, which means the radius would be 10. And this is the height that I'm going to plug into my formula. So it'll be pi times 10 squared plus 2 times pi times 10 times 50. So that's 100 pi plus, if you multiply this, it's going to be 100 times 10 or 1,000 pi. Since they're both like terms, that would be 1,100 pi square feet. Now, what you're dealing with there is exact, but you need to know approximately how many gallons. So you're going to have to plug in pi to get an approximation. And if you do that, you're going to get 3455.8 square feet. That's how many square feet you're going to cover. That is not the answer to the question. The question said, assuming that each gallon covers 1,000 square feet, how many gallons will you need? So divide this by 1,000, and if you do that, you're going to get 3 0.455 dot dot dot, but you're going to end up having to round up and buy 4 gallons. I know what you're thinking, that does not round to 4. It's not a matter of rounding, it's a matter that you can't buy a fraction of a gallon. Assuming it's only sold by the gallon, you're going to have to buy 4 gallons to have enough for your job. Okay, so that should get you through this section's homework on surface area. Next time, we're going to go to the one base shapes, which are pyramids, cones, and then the spheres. Bye.